Hello, and thank you for joining us today. Some of you might have been with us last time when we talked about the control.Node Complete Coding Solutions set. It's part of our STEM Sense line. It's a great way to get students engaged in science, mathematics, programming, computational thinking, but PASCO now is unveiling the next step in our STEM Sense line, and it is Sense and Control. So today we're going to highlight our three new kits that we have: the control.Node Control Node Sense and Control Kit, the Greenhouse Control Kit, and the PASCObot Sense and Control Kit. You'll get a tease on all of these things, and we wanted to give you a highlight today because at the end of the week we will be uploading all of our lessons that complement these kits along with get started videos, and we'll share the link to where you can get to our STEM Sense pages to access that information later this week. So let's go ahead and dive into these kits. So I was a STEM lab teacher prior to coming to PASCO, and I had multiple preps. I had different grades of students, and I really wanted to get into more tech with my students. But when you're switching from one grade to the next or one prep to the next, it's tough doing programming with a lot of bits and pieces and wires and soldering boards. So these kits take all that away for you. We include everything in the kit that you need to do the activities. And for this one, we now are introducing the control node. So what's really special about this device is you can use data inputs from the code node: brightness, light, sound, acceleration, and you can program physical outputs. You can actually make things move using the control node. So this kit, it's an engineering style kit. So we have all sorts of accessories that students can use along with the code node and the control node when they're programming in Blockly. We have a servo motor, we have a high-speed stepper, we have a USB fan. We even have the screwdriver, the rubber bands, the paper clips, the string, everything that you need. So we're going to give you a little bit of a tease to show you one of the activities, actually two, that you can do with your students with this kit. All right, so I'm going to take you into Blockly, and let's talk about the real-time data collection, because the coding is important. We really want to drive home with that, but we also want to emphasize that PASCO, we've been doing data analysis with our wireless sensors and passport sensors for many, many years, and it continues with this line. So I have my code node connected, and right now you're seeing tilt angle X, and there's a reason I'm going to show you this. So I'm going to start collecting data, and I'm going to tilt my code node back and forth. Actually, and I'm going to stop it for a second because I don't want you to see my program just yet. I should have disabled that. Okay, so I'm going to do it again. I'm going to click Start, move my control node. Let's try that one more time. I think I freaked the program out. There we go. I go back and forth, and that's tilt X. If you went forwards and backwards, that's tilt Y. For this program I've created, I want to use tilt X. So let me show you how that works. I'm going to go back to the code block and switch over to my code. So this is essentially what I created. The students are challenged with creating a meter that moves based on the tilt of the code node. So if I tilt the code node 90 degrees, it's going to go to 90 degrees. If I keep it flat on its surface, it should be at 0. So let's see how I did. All right, I'm going to press Start. Okay, should be at 0, and I am. And I'm going to tilt my device back and forth. And you can see I'm using the input from the code node to move this meter here. So that's one of the activities the students can work through. But let's kick it up a notch and give them another challenge. So now we understand how to program this servo motor. That's the main thing the students are learning in this activity, is how to program angles with that servo. Now they're going to turn this into a game. So if you've used the code node before, you might have seen that we have a number cube game where when the students shake the code node, it shows the number on the 5x5 LED array. Well, we've kind of combined that with this activity. And now it's going to let me know what number I rolled on my number cube based on the angles. So I'm going to go back here and I'm going to open my second program. All right, and I'm going to be using acceleration Y in this program, and let me show you the code. So now you can see we've gotten a little bit more advanced here. We've added a lot more. We've programmed the code node to show the numbers on the 5x5 LED array as I shake the device, and then this arrow is going to turn to the number that I roll here. Let's see how I did. I'm showing a 4, and I go to 4. I tape that a little bit too low. Roll to 2. Roll to 5. And it's randomized, so sometimes you're going to get the same number. But how cool is that? I'm able to actually create a game with my knowledge of understanding how to program a servo, with understanding how to use the input from this device, all the sensors that are within it. So that's just one example of what you can do. Again, we're going to have multiple activities uploaded by the end of the week for you to access. So that's our first kit. Control node, sense, and control. And it all fits in this box too, which is pretty cool. But I'm going to get it out of the way, and I'm going to introduce Miss Barbara. She's going to showcase the greenhouse.
Well, let me talk a little bit about the greenhouse before I start showing you the sense and control capabilities of this kit. Let's talk about photosynthesis, because that's what keeps plants alive, keeps them growing. What do we need for photosynthesis? Well, we've got to take in carbon dioxide and water. How do you get that to happen in a closed system? Well, with the control node and the greenhouse sense and control kit, you can have your water reservoir. This is where the water is coming from. There's a USB pump that's submersible that you can sink into your water reservoir to water your plant based on your program. How do we get CO2 into the chamber? There's a fan that is USB controlled through the power output. So both the USB pump and USB fan are controlled through this piece. And so the carbon dioxide gas that the plant needs can come in and out with the fan, depending on how you set it up. So we also know that photosynthesis takes place in the presence of sunlight. Here's the sun right here, and this grow light has just red and blue rather than the entire spectrum, so students can do investigations on the effect of color of light, proportion of red versus blue, to see how that affects plant growth. So we've got all the inputs that the plant needs for photosynthesis, and now let's talk about the inputs in this kit. So I'm going to connect my control node. You notice the light turned off when I turned it on. So I'm connecting in SparkView. And the good news, the Blockly code and all the equipment and sensors that you see work with either SparkView or Capstone. Okay, now I am connected. And this program is just one of the first activities that students will do, and Heidi mentioned that there are some lab activities available on the Sense and Control page, or will be available by the end of the week. So when we walk through students through these labs, the first thing we want them to get acquainted with is how do we get inputs to work with code. So we keep it simple, and we'll just focus on the light input for now, or output rather. So this program, I'm going to hit start, and let's see if you can figure out what it's doing. I don't know if you can see that, but it's very low intensity red light only, and now a little bit of blue's coming on. This light is starting to increase in intensity more and more. Well, you're looking at a model of sunrise, from darkness and sunrise, where it's kind of just the red light, and then as we get later on in the day, the intensity of the light increases just like the sun. If we look at the data in SparkView, you can also see that there's emoji there you can put as a text output and also words to explain what's happening. But also you can look at the data to make sure that you're coding what you think you're coding and the output is what you think it is. Okay, so now we can see that we're past noon and we're going towards the afternoon, towards the end of the day. It's getting darker and darker as the intensity is decreasing. And it's going really fast because, and well, it says sunset, now it's dark. And this is going to repeat in a loop. And while that's repeating, it's going to turn on while I'm talking. I'm going to go to the code and show you what's happening while it's running. So in the code here, wow, this looks complicated. You could do a simple version of this code, just say turn on for X number of seconds, then change to a different intensity for X number of seconds, and then another intensity and so on, and then turn off for X seconds. Or you can get more complicated. So there's all kinds of levels of coding ability that we cover in the program. So here we're just using a list. So if we look in the program, it's just saying every so often change the intensity of red and blue light and put a different message. And the reason why it's going so fast is because I have my time set to milliseconds. Let me make that a little bit bigger. That's a little bit of a cheat thing, because if you want this actually to run and keep the plant alive for a full day, don't you want it to run for 24 hours? Yeah, but if you want to test it, you can't sit there and watch it for 24 hours, so I can hit stop, and I can change from seconds to milliseconds. This is a little trick you can do to check something that might take a long time to look at. Okay, so that's one use of coding, and so far we only had control here. I didn't show you sense and control quite yet. We did see the brightness. We're just measuring the output. We saw a sensor measurement, but let's look at sense and control now. I'm going to open a different file, kind of on the same page here using the light. Now, one of the problems when we humans try to recreate the sun, we also recreate the heat. So that can be a problem in a closed chamber. So you're going to want to use a fan, not only to help the air move so you get more carbon dioxide to the plant, but also because temperature increases and it's a way to keep the chamber cool. Now I've got some data here that shows temperature on the top graph and brightness on the bottom graph. And if I turn on my tool to look at both runs at the same time, there's all kinds of analysis tools built into the software. You can see that the temperature is starting to go up higher and higher and higher, even though the light brightness shown on the bottom is not increasing, but it's getting warmer and warmer. So what's happening? It gets so warm, and once it hits 22.7, something happens. The red line shows the brightness drops. So how am I trying to cool down the chamber? Well, I'm going to make it a little less bright, and that'll put less heat in the chamber. Now I can see the effect of that. It eventually starts to cool down. Okay, now it's cool enough to go back up and get bright again. Then it gets warm, and then the bright goes down. So we can do this cycle of controlling temperature by cycling light up, down, turning the fan on, and getting the temperature where we want. So that's another application. Here's the code. It's actually, this code was created using something out of the function library. And to do a little bit more of the function library, I think I'm going to turn it over to Dan to show you how the function library works. There are functions for the greenhouse, but let's talk about the bot with my colleague Dan.
Yeah, over here at the kids table, but the PASCObot Sense and Control Kit is not a kid's toy. It's a highly engineered, engaging tool for teaching coding and physics and maybe some math too, depending on what your purposes are. I've got two of them here. This one we'll get to later. This one is outfitted with the gripper and also has the rangefinder on it. But I'm just going to use the basic bot with the control node for this first example. And what we're going to do is tell the bot to move in a precise way. So first we need to connect it to SparkView. And so on the bottom here is a power button. And now I've got the Bluetooth activated. And over here with SparkView, and again, we could use Capstone as well. I'm going to connect to the control node, which is the brain of the PASCObot. And the first thing I see are all these things I could get data from. I can get the angle and angular velocity, position and velocity of each of the stepper motors on the wheels. I can get the distance from the rangefinder, and I can get the acceleration from the built-in accelerometer and the servo current. In this case, I'm going to pick the position and velocity of the left stepper motor because that'll give me positive values when it's going forward, which seems to make sense. And I'll uncheck everything else here. And let's make a graph. And we'll come back to this graph later, because before we can get it to graph anything, we need to tell it what to do. So I click on the code window, and the stepper motor block is here in the hardware menu. And that is a powerful tool for telling the stepper motor everything you need it to. But it'd be better to bring in a function that's already built to use that block. So I'm going to bring in from the PASCO code library, move a distance. And so that will move the PASCObot the distance I put here, in this case in centimeters. And so this is calling this function. So I'll put that function out of the way here. If I want more of those, they now appear in the function menu, so I can pull them out if I want and have it move any number of distances. Then it'd be also good if we could get it to turn, and you can have it do curve turns or just a quick 90-degree turn. I'm going to do that and bring in the turn left or right function from the library. So there's the left and the turn right functions. And what I'm going to do is have it go in a rectangle. And so I have to picture which way is that going to go. It's going to turn right. I'm going to have it go clockwise. So I can do that. I can pull more. Now notice the turn right and left show up here. So I can pull more of them out, or I can do a right click and duplicate whatever blocks I want. And that makes things go pretty fast too. And let's have it turn right at the end too. So it's kind of back where it started. And then I need to tell it how far to go. So I worked out ahead of time that with this table, I can get it to go that far. And again, we want to duplicate this math block. And then we'll have it go 35 on the short side. And one more here. You can put in any dimensions you want. I'm limited by the table. And then notice this turn left is still here. It's going to execute that. So I could delete it, and I can always pull another one, or you can disable blocks that you might want to use later. And so I have it ready to go, but let's go back to the display window. So I just click on the, it's like a toggle button, right? It goes between the code window and the graph window. And let's see what it does. Hopefully what it did in rehearsal. No. I just don't have faith in it, but it doesn't go off. And look at the graph of position and velocity. I'm getting a whole lot of questions when I look at that. So if you want students to understand and learn kinematics with the PASCObot, this is a perfect tool, as well as physics. Now that was successful, but that isn't where the learning occurs. The learning occurs when you're trying to do things and it doesn't work. And with coding, a lot of times that's just, oh, the code doesn't run. But to me, it's much more engaging when you see it do something you didn't expect from your code. You immediately want to open the code and see, why did it do that? What can I learn from that? How can I become a better coder? And so that's the experience your students will have over and over again. Another thing I wanted to show is the line follower. This one is outfitted with the line follower. And I'm going to use a feature that's in here. If I go back to the code window, another option for running the code is I can upload it directly to the control node using these buttons up here. And so I've already done that for the line follower program, and that's a good thing for the line follower program because it can react faster and it works better if I do that. Also, I can have, this is a pretty neat trick, I can have the code on the computer turning on and off the code that's already uploaded to the control node. Once I realized you could do that, the possibilities for what you can do with the line follower and other things just exploded. So when I turn this on and then hit the button again, it's going to run the code that I already uploaded. And it's following the line using 4 infrared lights that shine down, and then we measure with 4 sensors the reflected light. And so beforehand I had to tell it how much reflection comes off the white tape, how much comes off the table, and it then is able to try and keep the tape in the center of those sensors as it goes. And then as a little extra, I programmed it so that it would turn around when it runs into a line of tape that's crosswise. In other words, all 4 sensors measure the tape rather than just in the middle. So once students start playing with this, again, not playing, working, learning, they're going to want to come up with way cooler things than this. I'm kind of, again, limited here at the kids' table. Now, we mentioned there was a built-in accelerometer in here, and so I also put in the code a function that will, a command that will turn it off if the accelerometer measures that it's been tipped up. Tipped up. There. So that's kind of a great thing to do without having to turn it off. You can just turn it off too. You can also execute it using SparkView. Well, again, we didn't use the gripper or the rangefinder with this one. Let's do that. And so in this case, I'm going to open up something I've already coded. So I made a graph of distance. And so what is the distance? Well, it's the distance from the rangefinder in front here. The rangefinder sends out pulses of infrared light and measures the time it takes it to return. Knowing the speed of light, it can figure out how far away things are. So if I hit start, it starts the program. The code is looking for when I place this cup in front of it. If I put it, well, notice the range is 0. If it's not detecting anything in front of it, it just says 0. If I put the cup here, it found the cup, but the cup's about 40 centimeters away. The code is going to start activating if I get it closer than that, about 30. There, now it finds it, picks it up, and does, well, whatever I put in the code, at least after playing around with it for a while. Oh, did you hear that? There's a speaker in it too, as we heard over there. And so you can add, a backup beeper, or in this case, a little yay, I did it message. Hopefully I've just, shown you some things that make you want to investigate this further, but we just don't have time to go through everything we could do. If only I had, wouldn't I need my own webinar to go through everything with the PASCObot Sense and Control Kit? And so join us again on April 13th, and we'll go through a lot more with the PASCObot. Thanks for joining us today, and we hope you check out all of our STEM Sense products on the PASCO.com website. See you next time.